So I will be talking about rate laws and reaction orders. So in this experiment, we ran 3 different trials, 1, 2, and 3, and we had 2 solutions, solution A and solution B, and they have different concentrations. And when we mix the 2 together, depending on the concentrations, they ended up with different rates. So we want to find the order of each reactant, A and B. And in order to do that, you have to use the rate law equation. So in order to determine the order of A and B, you have to use the rate law equation, which is rate equals K, which is our rate law constant, times the concentration of A to the X times the concentration of B to the Y. So in order to find the order of A, you have to pick 2 trials in which the concentration of B, they are identical. So in this case, we would pick trial 1 and trial 2. So you take the rate. We're going to start with trial 2, which would be 2.72 times 10 to the negative 4 equals K, which we're just going to leave it as K, times the concentration of A, which is 3.0 times 10 to the negative 3rd to the X, times the concentration of B, which is 1.5 times 10 to the negative 3rd to the Y. Now we're going to divide that by trial 1, which the rate is 1.36 times 10 to the negative 4th equals K, times the concentration of A, which is 1.5 times 10 to the negative 3rd to the X, times the concentration of B, which is also 1.5 times 10 to the negative 3rd Y. So when we do that, the K's cancel out because they're exactly the same, and so do our concentration of B. So when we divide 2.72 divided by 1.36, we get 2, which equals 3.0 divided by 1.5, we also get 2 to the X. So in this case, our X would equal 1. So A would be first order. So in order to find the order B, we do the exact same thing, only we need to find 2 trials where the concentration of A is exactly the same. So in this case, we would use trial 1 and trial 3. So when we start with trial 3, our rate is 2.72 times 10 to the negative 4th, which equals K, times A, which is 1.5 times 10 to the negative 3rd to the X, times B, which is 3.0 times 10 to the negative 3rd to the Y, divided by the rate of trial 1, which is 1.36 times 10 to the negative 4th equals K, times the concentration of A, 1.5 times 10 to the negative 3rd to the X, times the concentration of B, 1.5 times 10 to the negative 3rd to the Y. So when we do that, our K's cancel out again. And this time, our concentration of A is cancel out. So we're left with 2 equals 2 to the Y. So our Y equals 1 again. So B is also first order. So in order for you to get a second order reaction, you would have to have this like be double this, where 2 to the Y would equal 4. So then it'd be a squared, so it'd be second. So now we're going to talk about K. In our rate law equation, so our rate law constant is K, which equals 1 over meters times, this is of your reaction, which in our case we had 2 first-order reactants, so that would be 1 minus 1. So in our case we would have meters to the first power times second